This question is about simple harmonic motion and the relationship between the displacement and the kinetic energy. Now, looking at this, we're given the displacement time graph, and I want to show how that, or I have to show what that relates to in terms of the kinetic energy. My way to do this is to convert the displacement time graph into a velocity time graph, and then I will look at what happens when you square that. So the displacement time graph looks like that, and we've got some key values. We've got t, which is one full cycle, that will be a half t, this will be a quarter t, and this will be 3/4 t. Now, thinking about what's happening, it starts off at the equilibrium position, goes up to a positive maximum, and then will go down back to the equilibrium position and to a negative maximum. Now, as it's moving, it is moving with a positive velocity here because its displacement becomes positive. So it's a maximum positive velocity here. At the equilibrium position, the speed is 0. At this point, it's about to move into the negative displacement. So it's got a negative maximum velocity. At this point, it's back to 0. And at this point, it is back to where we were at the start, which is like this. So hopefully you'll be familiar that there is a pi by 4 difference in phase for the velocity time graph compared to the displacement time graph. So now I've got what the velocity time graph looks like, then I'm looking to square it. So if I square it, it's never negative. The concept of negative energy in this context doesn't make any sense. So you end up with it only ever being positive, which rules out the first two graphs. So I'm left with the final two. Then the KE, if I think about what it would look like when the velocity is at a maximum, it will be at a maximum. When the velocity is 0, it will be 0. When the velocity is a negative maximum, it's a maximum, and at 0, and at 0. And I can see from the shape of the graph that it's D because it looks like this.